This is the part 2 video of the basic electronics. I hope you have seen the part 1 video. In this video we will cover about transistors, ICs, circuit boards, measuring instruments, and at last difference between microprocessor versus microcontroller. Transistors. What is a transistor? Transistor is a semiconductor device used to amplify or switch electronic signals and electric power. Generally transistors are two types, BJTs and FETs. BJT is known as bipolar junction transistor and FET is known as field effect transistor. Let us discuss about BJTs. BJT. A bipolar junction transistor is a three-terminal semiconductor device that is used for amplification and switching purpose. It is a current controlled device. This is a BJT counting from left to right and putting the flat side of BJT up, and the three terminals are emitter. One is emitter and 2 is base and 3 is collector. BJTs are two types, PNP and NPN. PNP transistor is formed by sandwiching an N-type semiconductor between two P-type semiconductors, and an NPN transistor is formed by sandwiching a P-type semiconductor between two N-type semiconductors. In PNP transistor, holes are majority charge carriers, and in NPN transistor, electrons are majority charge carriers. So in PNP transistor, current flows from emitter to collector, and in NPN transistor, current flows from collector to emitter. Let's see how an NPN transistor works. In NPN transistor, the left hand region is emitter region, it is highly doped. The middle one is base region, it is lightly doped. And the right hand region is collector region, it is moderately doped. In this, emitter base junction is forward biased and the collector base junction is reverse biased. Because the emitter end region is connected to negative terminal of this battery and the collector end region is connected to positive terminal of this battery. So the depletion layer width is also different. For forward bias, the depletion layer width is low, and for reverse bias, it is high. During forward applied potential at the emitter junction allows movement of electrons from emitter to holes in the base region. Because of lightly doped of base region, only few electrons will combine with the holes in the base region, and the rest will move towards the collector region. This is so because the reverse applied voltage at this collector base junction provides strong electrostatic field to the electrons moving from emitter region to the collector region. Also, after certain period of time, electrons move from their base region to outside of their metallic baselet as valence electrons. These electrons form an external base current, and these electrons eventually return to their emitter region. Generally, the base current is very small due to only few electrons combined with holes in the base region. We know that the emitter current is equal to sum of the base current and collector current. Therefore, the emitter current is slightly greater than collector current. Next, by plotting the graph between collector current and voltage difference between collector and emitter, we get three different regions. One, active region, when base emitter junction and base collector junctions are forward and reverse biased respectively. Cutoff region, when both base emitter junction and base collector junctions are reverse biased. Saturation region, when both base emitter junction and base collector junctions are forward biased. And this transistor work as a switch in on condition in saturation region and in off condition in cutoff region, and work as an amplifier in active region. Beta is equal to IC by IB. Here beta is known as current gain.
We are continuing with the transistors. BJT is explained by Lokesh, so we can move to the MOSFETs. What is a MOSFET? Before asking this question, we have to study about MOS. Just assume a capacitor in which two conducting plates are replaced by a metal and a semiconductor. In between there is an oxide. Most commonly silicon dioxide is using act as a dielectric medium. Here, terminal at the metal side is known as gate and the terminal at the semiconductor side is known as base. MOS having three regions of operation, that is accumulation, depletion, inversion. Inversion region of the operation is important one here. Here we have taken P-type semiconductor. Holes are the majority carriers in it. So what happens if we applied more positive charge towards the gate side, that is the metal side? Holes in the P-type semiconductor will repel and move away from the oxide semiconductor junction, and electrons will attract towards the oxide semiconductor junction. Here, negative charge layer formed in the P-type. It is inverse of behavior, so it is known as inversion layer. Voltage at which inversion layer forms is known as threshold voltage. We have discussed about MOS and inversion region of operation, so it is easy to understand about MOSFET. MOSFET is simply metal oxide semiconductor field effect transistor. If the substrate is p-type, then it is known as n-channel MOSFET. If the substrate is n-type, then it is known as p-channel MOSFET. Here we can see the symbol of the n-channel and p-channel MOSFET. Now we can check a 3D animation about structure of a MOSFET. In p-type substrate, we are fabricating two n-type regions. One acts as a source and other acts as a drain. Here we are adding a oxide and above which we are adding a metal. It is act as a gate. It is simply a metal oxide semiconductor. That is our MOS. We know that MOSFET is a three-terminal device. For describing its operation, we need some terms. VGS. VGS is the voltage difference applied between gate and the source. VDS is the voltage difference applied between drain and the source. VDS is the threshold voltage. It is the voltage at which inversion layer forms. VOV is the overdrive voltage. We will look into that later. ID is the drain current. Source is supplying electrons to the channel and drain is receiving electrons from the channel. So the drain current is directed from the drain to source. Here what we are doing is we are varying these voltages and we are studying the variation of the ID. One important point to be remembered is inversion layer acts as a channel or medium for ID. If there is no inversion layer, there is no ID. There are three regions of operation for MOSFET: cutoff region, linear or triode region, saturation region. First one is cutoff region. In cutoff region, voltage at the gate side is less than the threshold voltage, so there is no formation of inversion layer, there is no drain current. In water analogy, there is no this blue pipe, there is no channel, so there is no water flow. Second region of operation is linear region or triode region. Here, voltage at the gate side is greater than the threshold voltage, so there is an inversion layer or a channel for drain current, so that drain current is directly proportional to VDS. In water analogy, while opening the valve, water flow also increasing in a linear relation, but there is one more condition should be satisfied: VDS should be positive and less than overdrive voltage. Third region of operation is saturation region, and the condition is VG is greater than VTH and VD is greater than VOV. Before that, we have to discuss about overdrive voltage. Overdrive voltage is simply VGS minus VTH. And what is exactly happening at VDS is equal to overdrive voltage. In MOSFET, there are two PN junctions and we are reverse biasing it. PN junction at the drain side is more reverse biased than PN junction at the source side, so that depletion region width of the PN junction at the drain side is greater than depletion region width of the PN junction at the source side. When depletion region width increases, inversion layer width decreases. Therefore, towards the drain side, inversion layer width decreases. At VDS is equal to overdrive voltage, inversion layer at the drain side is almost tends to 0. Therefore, no further increase in drain current if VDS is greater than overdrive voltage. In water analogy, we have completely opened this valve, so there is no further increase in water flow. By this, we have completed discussion about transistors. Let's check remaining parts. Integrated circuits. We all know about Intel and AMD, right? Because these two companies are the leading manufacturers of the ICs. ICs actually, in a semiconductor wafer, millions and trillions of the resistor, capacitor, transistor-like components are fabricated. ICs are the building block of the most of the electronic devices, so it is also known as heart or brain of the electronic devices. Then applications of ICs. ICs have enormous applications in our daily life. We know that ICs are the major component of our computers and we can do several things using our computers, right? Like gaming, browsing, video processing, audio processing, etc. It is also part of counters, calculators, temperature sensors, radio receivers, like most of the electronic devices that we are using. Here we can see the first IC developed by Jack Kilby. Next topic is power sources. There are mainly two types, DC sources and AC sources. And again there is one more classification, that is dependent sources and independent sources. Voltage controlled current source, voltage controlled voltage source, current controlled voltage source, current controlled current source are examples of dependent sources. We have understood about circuits and different components. Now we have to make a circuit. Before that we should prototype and test it. Breadboards, dot boards and PCBs are used for it. First one is breadboard. There are a lot of holes drilled in it. These two are vertically connected and these 5 holes are horizontally connected, and there is no interconnection between this half and this half. By knowing these interconnections, we can make so many circuits. This is an example of simple LED circuit, and soldering is not required in breadboard. Second one is dot board. It is also called dot PCB. It is a thin rigid sheet with holes pre-drilled in it. We can make prototype of our circuit by inserting our components into these holes and soldering it. Here we have our thin PCB, that is printed circuit boards. We can use PCB to make permanent prototypes by soldering it. Here we can see some holes and the lines. Holes are obviously used to insert the components, and lines are the interconnection between the holes by conductive copper. We can design PCBs according to our own requirements. Proteus is the software used to design PCBs, and there are several types of the PCBs, and we are not going that much deeper into the structure part. Logesh will continue measuring instruments and remaining part of the basic electronics.
Measuring instruments. This is an ammeter. An ammeter is a measuring instrument used to measure the current in a circuit. For the current to be measured, ammeter should be connected in series to the circuit. For to measure current accurately, it is usually have very low resistance. Next, the voltmeter. It is used for measuring the electric potential difference between 2 points in an electric circuit. It has very high resistance so that it takes negligible current from the circuit. It is connected in parallel with a device to measure its voltage. Next is about multimeter. As its name tells the matter that it can measure voltage, current and resistance. You can use this probe to switch to different measuring functions. Generally in labs, black wire is used to connect to negative terminal and red for positive terminal. Multimeter is a standard tool for technicians in the electronic industries. We have moved to our last topic, microprocessor was microcontroller. What are these and what are their purposes in our daily life? Microprocessor is an integrated circuit chip used by a computer to do its works like gaming, web browsing, photo editing, creating documents, mathematical calculations, simulations, etc. These are the works done in our computer or in our cell phones, right? While a microcontroller is a compressed microcomputer manufactured to control the functions of embedded system. Embedded system means that is designed to perform a dedicated function or a task. Applications of microcontrollers are used in digital cameras, washing machines, microwave ovens, etc. These devices are made for specific tasks only. A camera can't do the work of a washing machine, and a washing machine can't capture a picture, right? But a microprocessor can do multiple tasks in our computer like these applications. Let us discuss about their structures. Memory and input-output devices are connected externally for microprocessor. For microcontroller, they are connected internally. Complexity of microprocessor is high, so cost of making is also higher than microcontroller. For power consumption is also higher in microprocessor than in microcontroller. Memory or storage required for microprocessor is very much higher than microcontroller because it has to store previous and present data to process, like for gaming and photo editing in our computer. As coming to microcontroller, it requires only a flash memory because it only do specific tasks and has nothing to do with previous data. We have completed our presentation. Thank you.